Hey there guys, welcome to the video for Patterns for Factoring Day 1. This is our 4.3 lesson and it's going to use still factoring but just a bit of more specialized type of factoring or patterns for factoring. So first we're going to start with a difference of two squares. Now when we say a difference of two squares, we mean that difference means to subtract, and difference of two squares means that we have two perfect squares. Remember, perfect squares are numbers whose product is from two numbers being multiplied by itself. So for example, 1 is a perfect square because it comes from 1 times 1. 4 is a perfect square because it comes from 2 times 2. 9 comes from 3 times 3. 16 comes from 4 times 4, so on and so forth. So these are all our perfect squares up to 12. We have more than 12, 13 squared is 169, and you can keep going and keep going. But this should be about all you need for your practice. Now, to recognize that you have a difference of two squares, you'll have a two-termed expression that being subtracted, which comes from the name of difference, and both terms in your expression are perfect squares. You can expand it out, or its original form would have come from the factor form of a plus b and a minus b. So we'll see what this means with some examples. So first off, I do see that I have two terms, and I do see that I am subtracting. So this is a hint that I have maybe a difference of two squares. First, I have to verify, are these two squares? Well, I know that 121 is actually, if you look up here, 11 squared. So 11x squared is how I would get 121x squared. Because 11 squared is 121 and x squared is x squared. Minus 25, most people know this one is a perfect square. And it's 5 squared. So what this is going to mean is that my a value is going to be 11x. And my b value is going to be 5. So this is what I'm going to plug into my equation. So my equation is a plus b and a minus b. So let's start plugging things in. Once again, I said my a was 11x, so 11x. Keep the plus my b value, which I said was 5. And then my a value again, 11x, minus my b value, which I said was 5. That's it. That's my answer. Relatively straightforward. You just have to identify what your a value is, what your b value is, and then just plug it into this form. Now, obviously, it's pretty straightforward once you're told or once you know, because we're in the difference of two squared section. The hard part is recognizing that you do have a difference of two squared when it's all mixed together. But we can practice a few more times. So here, it's okay if the x squared is not the first. You still could have you can still have a difference of two squares because we still have two terms. And then we have to check to see, okay, am I subtracting two perfect squares? Well, 49 is a perfect square. 49 is 7 squared. And then, minus, I know 64 is 8 times 8. So this one is also a perfect square. Because 8 squared is 64, x squared is x. And all I'm doing is saying, hey, this is my b, this is my a. The numbers that are getting squared without the squares. So a is 7, and b this time is the 8x. So then when I plug it in, it's going to be in the form of a plus b, so my a value is 7. Oop, let me color code. 7 plus my b value, which is 8x. And then my a value minus my b value, so 7 minus my b value. And that's it. That's your answer. So like I said, pretty straightforward once you've identified your A and B. So we'll have two more examples for these. So once again, I'm going to have to rewrite this as a difference of two squares. So I need to figure out what my squares are underneath this. I know 16 is 4 times 4. But this time, instead of m to the second power, m squared, I have m to the fourth power. That's okay. What's really going on here is that I have m, or 4m squared, squared. Because 4 squared is 16, and m squared is m to the fourth power, because 2 times 2 is 4. So those are your exponent rules. So this is still okay, even if it's to the fourth power. So even though you have 2 to the fourth power, as long as it's two terms that are being subtracted, and both of them are perfect squares, you're okay. Minus 81, which is just 9 squared. So this will be my A, and the 9 will be my B. So A is 4m squared, and my B is 9. So same thing as before, it's going to be A plus B. So 4m squared plus my B. So in this case, my B is going to be the 9. And then A minus B. So the 4m squared minus the 9. And once again, that goes straight to my answer. So a little bit more tricky, but once you've seen this, you can do the problems again. So once again, once you've seen this, you're like, oh, I've seen a problem like this before, and I know that d to the fourth power is okay as long as the 81 is a perfect square. Because I know d to the fourth power is a perfect square, it's just d squared squared. And I know 81 is a perfect square. It's actually 9 times 9. So this is 9d squared squared minus 2 squared, where 2 is my B, and 9d squared is my A. So A is 9d squared, and B is 2. So you're going to have 9d squared plus your B value, so A plus B, 2, and then your A value minus your B value, so 9d squared minus my B value, which was 2. Now, if you're saying, okay, but how do I know if I've done it correctly? You can always check your answers. So if I go back to my original problem here, so let's say I had 11x plus 5 and my 11x minus 5, I can do my double distribute. So I can say, okay, let me do 11x multiplied to both terms in the second parenthesis. So 11x times 11x is 121x squared. 11x times negative 5 is negative 55x. And then double distribute means I have to distribute my second term in the parentheses. 5 times 11x is 55x. And 5 times negative 5 is negative 25. I can combine my middle terms, which notice negative 55 plus 55 cancels out, and that gives me 0. So that'll leave me with 121x squared minus 25, and notice that matches my original problem. So you can double distribute to check your answer. And if it matches the original problem, you've known you've done it correctly. Now, the middle term should end up canceling out. That's what happens when you have the exact same thing except 1 plus 1 minus. When you double distribute, you end up with your middle terms having a positive version of it and a negative version of it. So it'll cancel out, so you'll only have your first term squared and your last term squared. Now, something very similar, but something you probably haven't seen before. So you probably have seen perfect squares before. but you probably haven't, and you may have, but you probably haven't seen perfect cubes before. They follow the same idea. They're products of numbers multiplied by themselves 3 times. So not 2 times 3, but 2 times 2 times 2. So 1 times 1 times 1 is 1, so 1's a perfect square, or my bad, perfect cube. 2 times 2 is 4, times 2 is 8, that's a perfect cube. 3 times 3 is 9, times 3 is 27, perfect cube. 4 times 4 is 16, 16 times 4 is 64. You get the idea. These are all perfect cubes because they're all the same number multiplied by themselves 3 times. Now for perfect cubes, we have 2 different versions of our equations. If we have the sum of cubes, that means we have 2 cubed terms being added, then this is how we write our expression. If we have a difference of cubes, that is to say we are subtracting, then we write our equations in this type of expression. So, once again, you'll know you have a difference of cubes if you have a 2-termed expression again, and they're cubes, or the perfect cubes. So let's check this. Now the first one's pretty straightforward. P cubed is a perfect cube because it's just p to the 3rd power. And 1 is a perfect cube because it's 1 times 1 times 1. So this time, my A is p, and my B is 1. And then I need to check what symbol I have in the middle. Since I have an addition, that means I'm doing sum of cubes. So I need to do this version of my equation. Whoops, all of it. This version of my equation. So I'm going to do A plus B, so my A is P, plus my B value, which I have is 1. So that's my first part. And then parentheses A squared. So my A is P, so P squared, minus my AB. Now AB just means multiply your A and B value. P times 1 is just P. So you can have 1P, so I'll write 1P, or you can just have P by itself. It means the same thing. Plus my B squared. So my B is 1, so 1 squared is just 1. And once again, that's it. That's your answer. The main part is identifying what your A and B is and then just plugging them into this expression. Sometimes you'll have to simplify, but for the most part, that's all you have to do. So then we do the same thing here. J cubed is a perfect square because it's just J cubed. And 125 is a perfect square because it is, or my bad, perfect cube because it's 5 times 5 times 5. So it is up here. 5 times 5 times 5 is 125. So you don't have to have these memorized. You'll have this little chart above there. And when you take your test, you can write that chart on your note card. But this time, notice that we're subtracting. So this time, we're going to use this version of the equation. So if we're minusing 2 perfects, or we have a difference of cubes, still the same idea in that this is my A, so A is just J, and my B value is 5. So I'm going to plug it into my second expression. So A minus B, so my J minus my B value, which is 5, my A value squared, so J squared, plus A times B, so that's 5 times J, or J times 5, which is just 5J. And although it says AB, when we multiply 5 times J, or J times 5, you write it as 5J. And then plus your B squared. Now your B squared would be 5 squared, which is 25. And then remember, you got this because it's 5 squared. And once again, that's your answer. You just have to identify your A and your B values and then just plug them into the correct equation. So I have a two-termed expression. Now, although this one has sum of cubes and difference of cubes, we only have a difference of 2 squares. So this equation here only works for subtraction. So be careful here. If it's squared, you can only work with subtractions. Only for cubes that you'll have a positive and negative case. So 27 is a perfect cube, is 3 times 3 times 3. So this is 3k cubed plus 64. Be careful, it's not 8. 64 is a perfect square because it's 8 times 8, but we're talking about cubes. So when we're talking about cubes, we're going to reduce it to the 4 because it's 4 times 4 times 4. So it's 4 cubed. And I can identify my B value. So my B value is 4, and my A value, which is 3k. And this time, I'm adding, so I go back to the sum of cubes formula. So that's A plus B. So my A value is 3k, plus my B value, which is 4, A squared, which is 9k squared, because 3k squared, so I'll write it down here. This is just 3k squared. Because remember, it asks for a squared minus ab. So minus a times b, which is going to give you 12k. So this came from 3k times 4. And then finally, plus b squared. Plus b squared, which my b is 4, so this time 4 squared is 16. And this came from 4 squared. And this here is my answer. Once more, 216, once again, I don't expect you guys to have that memorized. It's a perfect cube, it's 6. 6 times 6 times 6. So this will be 6w cubed minus, and always be careful, 1, remember, is a perfect square and a perfect cube, because you still get the same product back. 1 times 1 is 1. 1 times 1 times 1 is still 1. So my A value is 6w, and my B value is 1. So it is A minus B, and you'll kind of get used to it once you've done them enough. If it's a sum of cubes, your first parentheses will be A plus B. If it's a difference of cubes, your first parentheses will be A minus B. And since we have a difference of cubes, we're going to have A minus B. So my A value is 6w minus my B value, which is 1. And then I'm going to do A squared, because both equations start with A squared. So A squared is going to be 36 w squared, because you have to square this one. So 6 squared is 36, w squared is w squared, plus A times B, which is just 6w, plus B squared, which is 1 squared, which is just 1. And there is my answer. So hopefully after you've done this quite a bit, you start getting into the habit. You may want to, each time you do it, rewrite the general formula just so you have it available to you, and so that it's easier to kind of memorize. You don't have to have it memorized, but it does help if it's memorized. It makes the problem go a little bit faster. Now this time, if you check your answers by remultiplying, it will take a while because you'll have to multiply a times a squared, a times ab, a times b squared, or in this case, 6w times 36w squared, 6w times 6w, 6w times 1, then negative 1 times here, negative 1 times here, negative 1 times here. That takes too long. So another thing you can do is you can graph your answers. And the original problem. And if they overlap, then you've done it correctly. Because remember, we, at the end, have the same expression. We're just rewriting it in a different form. So if you graph it, and it gives you the exact same thing. Now, when you graph it in your graphing calculator, make sure to turn everything to x's, but if they overlap, you've done it correctly. The last thing today is quadratic form. So the other two were pretty straightforward. You just have to identify your a and b values. This one, you actually have to go into factoring. So there's no general form. You just have to factor. So similar to your 4.2 lesson, where we had the factoring review. And that's why we did a factoring review, because this lesson assumes that you know how to factor going into it. So what we're going to do is that we are going to change our form into squared. So let's just remember how to factor in general. Remember, we do factor by grouping, which is where we're going to multiply your first and your last term. And that will be the number we have to multiply. So we have to multiply to be a negative 8. And then we want to find all factors of negative 8, such as 1 and 8, 2 and 4. And see which of these, now since this is negative 8, we want two numbers that subtract to be negative 7. Which I can do 1 times negative 8, which is negative 8, and 1 minus 8, which is negative 7. So I'm going to take my negative 7x and split it up into 1x minus 8x, and bring everything else down. So it didn't change the problem, because 1x minus 8x is still negative 7x, and everything else stayed the same. I'm just rewriting it so that it's ready for factor by grouping. So now I'm going to put parentheses are my first two terms, and I have to find the greatest common factor. So in this case, my greatest common factor is 1x. The biggest number that will divide into 1 and 2 is 1, and they both have an x, so I can pull out an x. And then remember, you just ask yourself, x times what is 2x squared? Well, x times 2x. And then there's a plus. X times what is 1x? Well, times 1. Because remember, once again, we're not changing the problem, we're just rewriting it. So x times 2x is 2x squared, x times 1 is 1x. And you'll do the same thing to this here. Now remember, if your leading coefficient in your parentheses is negative, you have to pull out that negative. So I have to pull out a negative. And the biggest number that divides into 8 and 4 is 4. That's my greatest common factor. They both do not have an x, so I don't pull an x out. And then you say, okay, well, negative 4 times what is negative 8x? Well, negative 4 times 2x. There's a minus sign. Negative 4 times what is negative 4? Well, negative 4 times 1. And positive 1. Negative 4 times positive 1 is negative 4. And remember, you know you've done it correctly if these two parentheses are the same. So for us, these two parentheses are exactly the same, so we've done it correctly. So I'm going to write it as 2x plus 1. And then take my greatest common factors. So I'm going to have x minus 4. So to solve these, they're the same idea. You just have to turn them, kind of, in a sense, into the form of x squared minus x minus this. So to turn this into a quadratic, we are going to first substitute So I'm going to say, hey, let u equal x squared. And I know that x to the 4th power, so if I rewrite it, and this is a bit confusing as you go through it, I know x squared is, or x to the 4th power is just x squared squared, minus my 7x minus my 4. Well, if I say that u is x squared, well, I have an x squared here, and I didn't write it, but you also have an x squared here. So what I'm going to do is I'm going to substitute these x squared values for u's. So when I rewrite it, I'll have 2 u squared, because it was x squared squared, minus 7 u minus 4.
Can I come tomorrow morning?
Generally all you're doing is you're turning the first one to a squared and the second one just to a normal value. We only do this so that we can factor by grouping like normal. So same idea, you're going to multiply your first and your last term. So 2 times 4, which is 8, negative 8 again. 1 and 8, 2 and 4. And you'll notice, if you compare these two problems, they're essentially the same problem. 2x squared minus 7x minus 4, 2u squared minus 7u minus 4. So we already know what the answer should be. We know the answer should be 2u plus 1 and u minus 4. But I said that u is equal to x squared. So this isn't my answer because I have to resubstitute in the x squared. So I'm going to have 2x squared plus 1 and x squared minus 4. So this is actually what my answer is because I had x to the 4th power. All this to say that you solve it in the regular manner that you would solve any other problem. The only difference is that you have to add in the x squareds for your answer instead of just having regular x's for your answers. Now, once again, you're technically not done because this right here, the x squared minus 4, is what we call a difference of 2 squares. So remember, a difference of 2 squares when you have two terms being subtracted and they're both perfect squares. And I know 4 is a perfect square because it's 4 times 4. So since this is a difference of 2 squares, I can rewrite it as parentheses. My 2x squared plus 1 will stay the same. But this is going to change into, this is purple, x plus 4 and x minus 4. And now that's your answer. So that's why we kind of put these together. The first two, difference of 2 squares and the sum and difference of cubes, are pretty straightforward as long as you know your a and b values. These are the ones that are going to be a little bit more tricky. Not too much, you'll just have to make sure to check to see if you have a difference of 2 squares. Nothing happens here. Remember, you don't have difference of 2 squares with addition, it's only with subtraction. And they might not always be difference of 2 squares. Now this part here isn't necessarily necessary. It's the correct mathematical form to do it, but you can. So in this problem, same idea that we did last time, we are going to factor our quartic expression. Remember, that's what you call it when it's 2 to the 4. We don't necessarily have to do this step where you substitute and say u is x squared and then replace everything with u's and then replace it back. It is the correct mathematical way to do it, but you can just keep in mind, hey, I'm just going to rewrite this expression as negative 4x squared plus 16x minus 12. And then keep in mind at the end, when you get your answers to look like this, you'll just put in the x squares where the x's are. So we're just going to factor as if it was just a regular quadratic expression, and then at the end, put r squares back in. Now, before we start factoring this, you always have to check to see if your expression has greatest common factors. That is, there are numbers that we can factor out. So if I see that I have a 4, a 16, and a 12, well, they're all divisible by 4, so my greatest common factor is 4. And remember, when your leading coefficient is negative, you have to pull out the negative. So I'm going to rewrite it as -4, and then we're going to kind of go out. And you can go either way. You can say, okay, -4 times what is -4x squared? Well, just x squared. -4 times what is positive 16x? Well, -4x. And then -4 times what is -12, and that is positive 3. At this point, you can factor by grouping. So I'm going to take my first and last term, which is 1 and 3. So I need to find factors of 1 and 3 that will become -4. Well, that's -1 and -3. So -1x minus 3x. And I'll bring everything else down. The plus 3, the x squared, and don't forget the -4 in front of my parentheses. And then you are going to put your parentheses in front of it and find your greatest common factor. Now the biggest number that goes into 1 and 1 is just 1. They both have an x. My greatest common factor is x. So I'll keep my -4 here. X. What times x is x squared? Well, x times x is x squared. And then x times what is -1x? Well, x times -1. Now remember, as I put parentheses around my next one and find my GCF, I can obviously see that my GCF is 3 because they're both 3. So I can divide both of them by 3. Remember, if your leading coefficient is negative, you have to pull out the negative. So my GCF is a -3. -3 times what is -3x? Well, -3 times x. And then -3 times what is positive 3? -1. Which makes sense because remember, you know you've done it right if your two parentheses are the same right here. So I'm going to take those parentheses, and that's going to be the first part of my answer, x minus 1. And then, remember, the next part of my answer is the GCFs, so the x minus 3. And then I still have my -4 at the front. Now, before I say this is my answer, you have to have a very, very last important step, which is to remember that, hey, remember earlier in the problem, we changed it so they're squares, but it's still a quartic problem. We still have x to the 4th power. So at the end, where I have my answers regularly, all you do is put squares where the x's are. And then check to see, do I have any difference of 2 squares? Now, 3 is not a perfect square. There's no number that multiplies by itself to get 3. But remember, 1 is a perfect square because 1 times 1 is 1. So you're going to have -4, x plus 1, x minus 1. So this became this because it's a perfect square. And then you'll keep your x squared minus 3. Looks very, very complicated. That's about as hard as these type of problems will get for today. Our last problem is 3 to the x to the 4th power minus 20t squared. That should be an x. Plus 12. So, same idea. I'm going to turn it just into a quadratic problem for now, and I'll just put in my x squareds back in at the end. So I'll solve it like a regular quadratic problem. Multiply my first and last term. 3 times 12 is 36. And my factors of 36 are 1 and 36, 2 and 18, 3 and 12. We need to find which of these combinations will add to be 20. Well, I can see 2 and 18. So I'm going to split this up into a -2x and a -18x. Because -2 times -18 is going to give you positive 36, and -2 minus 18 will give you the -20. And like last time, everything gets brought down. And you just do your regular factor by grouping. So what number goes into both 3 and 2? There is no number that will divide evenly into both 3 and 2, so we'll say our greatest common factor is 1. But they do both have an x, so I can pull out an x. And I know x times 3x is 3x squared, and x times negative 2 is negative 2x. For my next part, or my next set of pairs, I know that I can take a 6 out of it. Now be careful, 2 will divide into 8 and 12, but you want your greatest common factor, the biggest number that divides into both, which is a 6. And it has to be a negative 6, because you always have to pull out a negative if your first term is negative. So then we know that negative 6 times 3x is negative 18x, and negative 6 times 2, or negative 6 times negative 2, is positive 12, which, once again, we know we've done it correctly because our two parentheses match. They are the same. So that's going to give me 3x minus 2, and then my other parentheses will come from the greatest common factors, the x and the minus 6. And then remember, last step, I'm really dealing with a quartic expression, so you're just going to put x squared in front of them and check to see, do I have any difference of cubes? So 2 is not a perfect square. There's no number that multiplies by itself to be 2, because 1 times 1 is 1, 2 times 2 is 4. Same thing, 6 is not a perfect square. Nothing multiplies itself to be 6. So neither of them are perfect squares. So in this case, you leave your answer to look like this. So these are your examples. Very, very tricky compared to the first part of the notes. So you will have to practice a little bit more with quadratic factoring. But that's fine because you have a Delta Math assignment. So if you have questions, feel free to sign up for tutoring. Otherwise, have a nice day.